This 29th of October. It is holiday, national holiday, so we don't have class this Thursday. So that means this week we have only today have class. Good. So it was one detail. My friends, one of your friends asked me one question. So some students are really interested in the course. They are solving past year exam questions. So I just want to explain this to everyone. Can you see this Hesse diagram question? Can everyone see?
Yes, we can.
Yeah. He asked me why this is like that. So it will be a kind of revision for you also. My friends, what is the question? Partial order given, x divides y. Draw Hesse diagram of the relation. Now, as usual, we start with this set. We start with what? The smallest one, 3. Now, let me take my pencil if I need. Okay, so we start with 3. Now, does 3 divides 4? No. So this 4 has to be in the same level with 3. Now we continue. Does 4 divides 5? No. But we also look at, does 3 divides 5? No. So these all have to be in the same. Now, next one. Does 5 divide 7? No. Does 4 divide 7? No. Does 3 divide 7? No. After that, what comes? 10 comes. Now, 7 doesn't divide 10. But when I look at these guys, I can see that 5 divides 10. So I have to write 10 in the upper level. Okay, so I can draw a line. Now, and then again looking, these two guys doesn't divide this. So, okay, now I am in with 10. Now I go back to 11. Does 10 divide 11? No. Okay, I am going back now. Does 3 divide 11? No. Does 4 divide 11? No. Does 5 divide 11? No. Does 7 divide 11? No. So 11 has to be in that level. Because if you write 11 in this level, that means that one of them divides these guys. So this cannot be in the upper level of these guys. So we have to write this 11 in the same level. Okay. Now we continue. Does 11 divides 50? No. But when I look at these guys, I see that, for example, immediately 3 divides 15. 3 divides 15. So 15 has to be in the upper level of 3. Then you can make a line like that. What else? 5. You also have from here. Anything else? No. Now, next thing. Does 15 divide 16? No. And so it will really be in the same level with 15 because I can find one guy here at this 4 divides 16. Other guys, no. Okay, so I directly did this 16. After that, does 16 divide 32?
Yes, sir.
Yes.
So we have a line. 32 divides 52? No. It needs to be same level because there are guys here which divide this. So 4 divides, for example, 52. Now 52 divides 77? No. But 7 and 11 divide. So you get lines. At the end you have 104 and only 52 divides, so it should be here. Okay. Okay, guys. In here, what is the minimal? Yeah, what is the minimal? Minimals are 3, 4, 5, 7, 11. What are the maximal? 10, 15,
32,
77, 104. Can you see even this 77 here? You also take this as maximal. Because what is the definition? This cannot be less than any other, guys. Yes, see, this is 77 is not less than 7. This is not less than 11. And by the context, because you cannot compare this, so automatically you can say that this is not less than these ones. Do you understand? Because you cannot compare. So you automatically skip these cases. So 77 is maximal. So even this guy and this guy in the not same level. So this shouldn't confuse you. You should go through the definition. Why 52 is not maximal? Because it's less than one guy, 104. Do you understand?
Yes.
Can we say that they are not connected to the same branch? 15,
Yeah,
32.
yeah. This guy is like kind of different branch. Yeah, batch.
Okay.
Yeah, and this has, so this is like in a isolated with these three guys. They are here, and in here 77 only can comparable with 7 and 11. So of course that 77 cannot be less than others, because others, so these are automatically, because not comparable, so automatically not less, isn't it? Because if you compare, then you can say about less or not. If not comparable, so you just skip this. You understand the idea?
Yes.
Yeah, thank you.
Sir,
And
can I ask you a question?
yes,
Why can't we put 52 with the same level of 10 or 16?
okay, let's check. Which ones you say? 52?
Yeah, why don't we put 52 with the same level of 16?
Okay,
Or
if
10.
you, okay, I mean, you mean this ones, like 52,
Yeah.
why it's not here?
Yeah, that's what I'm asking.
Okay, now when we come this, let's check. 32, what we said here when we are coming, 32, okay. Okay, if we say, okay, the problem in here is this. If you put this 52 here, 32 will be in the upper part of this. So that means that this means that 50, so this divides this one, because whatever on the below level, okay, look, you have one level here, one level here, okay? Whatever you write this,
yes,
that means that this guy should divide this, can divide this. But if you write this 52 here, then this 32 will be like in the position of higher level of 52.
So can we say if there can't be the there can't be the lower number on the upside? Can we say that?
Upward. This one, you mean upward?
No, I want to say, I mean, for all of the numbers,
Yes.
there can't be any higher number on
Yeah. We
on
don't have
this
much.
next level.
There can't be higher. No, there can be in here. For example, you have 52, then you have 104. Maybe I don't understand your question.
Yeah, I mean, like, for example, the 15 can't be on the third line because it's 16 in the second line.
Yes.
So that's what I'm trying to say.
Yes, exactly. Yeah.
Okay.
Yeah.
Thank you very much.
Yeah. Okay,
Is
thank
it
you.
like because is it like because 32 is not comparable with 52, but 52 is comparable with 4?
Yes, 52 is comparable with 4. But
Okay.
52 is not
Not
comparable
comparable
with
with
32. Yeah. For example, in here, what we did, like at that moment, what we did, 10, 5, let's go back to this. 10 doesn't divide 11. Am I right? But we cannot write 11 in the same level all 10. Because if you write this in the upper part, that means one of them divides this. But we know that none of them divides this. So we write the 11 here. Do you understand? This actually answers your question, my friend. Why we didn't write 11 here? Even look, 10 doesn't divide 11. Why we didn't write 11 here in the same level? Because these guys doesn't divide 11. So we write 11 here.
Teacher, what about the 77? Why don't you put it next to the 10?
So then the 77 will be here. So 52 and 32 will be one up from them. But it cannot be because these are not comparable to each other. Do you understand?
No, I didn't get it.
It's the same thing. So if you write here, so these guys cannot be upper than this one from 77. Because this means if you write this, then this means that this can divide these guys. For example, why I didn't like 11 here to here? Because these guys doesn't divide 11. Okay. Anyway, just look at this. If you have question, I can explain again. Okay.
Okay.
Yeah, just and yeah, it's like that. And here maximal elements. We don't have maximum because we don't have a guy which is comparable with all of them. Okay.
Teacher.
Yes.
Is it acceptable to draw the acid diagram this other way? This one with this one.
Both of them same. You can do like that or like that. What is done here? Can you see that this like Z guy, not Z, but like this zigzag guy, you can separate from here and write like that.
All right.
Okay. Yeah. Okay. I'm finishing this. We can discuss again. You have a look again, but I need to start the new section. But we can come again. My friends, we were doing functions. Remember, we learned domain, we learned target. So if you have a function from A to B, you have domain. Domain is what? A. Target codomain is what? B. Range is a different thing. Range means that B is from B such that AB is in F for some A in A. That means that B is in B such that B is equals to F of A for some A in A. The function is onto or surjective. If it is range is target, that means range F is equals to B. Okay, what we said also, that is every B in B is of the form B is equals to F of A for some A in A. Equivalently, for any B in B, the equation B is equals to F of X has a solution X in A. It is one-to-one or injective if and only if different values of A have different images. In symbols, A1 not equals to A2 implies F of A1 not equals to F of A2. Equivalently, if F of A1 is equals to F of A2, then A1 has to be equals to A2. It is a bijection or bijective function if it is both one-to-one and onto. Okay, just I reminded you these facts. We did these examples, as you remember. Like, look at this one. This is domain A, target B. Range is what? Ranges are these guys, right? X, Y, Z. So target and range is the same, so it's onto. Now, is it one-to-one? No, because when F of 2 and F of 4 is the same, as you see, they both go to Y, but 2 is not same with 4. So it's not 1 to 1, or f is not bijective. Now, B is given like that. Here range is what? W/X. Range is again, here when we look at, is not equals to B. That means f is not onto. This is 1 to 1 by f of 1, f of 2, f of 3 are all different. And if f of A1 is equals to f of A2, A1 is equals to A2. Okay? Now, example 4, A, B is given. These two are, you have two functions, f and g, both of them from A to B. The domain of f is A. Yes, we know. Domain of g also A, yes. The range of f is what? Z and y. I'm not taking y 2 times because this is a set, you know, and z and y, which is a proper subset of B. So that means f is not onto because z and y is not equals to x, y, and z, you know, as a set. So this is not onto. On the other hand, g is onto because range of g is what? Z, y, x. This is exactly the B. Now, this function, I mean the g guy, is also 1 to 1 because g1, g2, g3 are all different. Okay, g1 is z, g2 is y, g3 is x. Okay, what else? This function also, okay. Yeah, if g1 a1 is equals to g of a2, then yes, a1 is equals to a2. So it's okay here. Oh, what about f? F is not 1 to 1. F of 2 is equals to f of 3. Both of them goes y, but 2 is not equals to 3. So this is not 1 to 1. Do you have any question with this? Okay,
No.
I think this, okay. Now have a look at this. Let f z to z, like integers, we know this. And it's given like f of x is equals to 2x minus 3. Domain is what? Z. Range is what? Now range, what you will do? B, let's say B in range, then B should be f of a for some a, right? This is f of a. Oh, okay, I write it here in more clearly. B is in range. That means B is equals to f of a for some integer a. What does this mean? B is equals to 2a minus 3. So this is coming from this fact. Now there is a trick here. I add -1, okay, and I add +1 to this expression. It doesn't affect because -1 plus 1 is 0. This now becomes what? 2a minus 4 plus 1. I can rewrite this like that. 2 times a minus 2 plus 1. This part is even, this part is odd. So that means at the end, B is odd. So so what is happening? If B is in range, it should be a odd integer. Now, range of f is the set of odd integers. It is not equals to integers. So f is not onto. It is 1 to 1. If f of x1 is f of x2, that means if 2x1 minus 3 is equals to 2x2 minus 3, then x1 is equals to x2. Okay? Here, let f natural numbers to natural numbers. F of x is 2x minus 3. This is not a function at all because f1 is what? -1. -1 is not in the natural number, so this is not a function. So this cannot be defined like that. Okay? So this is tricky. Understand?
Yes, yes.
Okay, you are very good student. Our class is very good. Okay, let's go. My friend, there is one question, but beforehand, I want to remind you these facts. Maybe before years you know this, but when you have quadratic equations, you have graph of these guys. I will not go to details. You have the parabols. So if a is bigger than 0, you have concave up. If a is less than 0, concave down. You have a vertex of the parabol. This is we will interested in. So the vertex, it depends on what you have. If the vertex, if you are looking with upward, then it is something tells you about the minimum, some other calculus things. So the vertex is a point, let's say H and K, okay, is a point on the parabol. It's either at the base or the top of the parabol, depending upon whether it opens upward or downward respectively. So in here at the base, in here at the up. So how do you find this vertex? Vertex is here, for example, in the case of A is less than no, not less than, sorry. If A is bigger than 0, because this is what? Up. You find H is what? Minus B over 2A. And K is just Y over Y of H, which is this. Now, why we need to find the vertex of this? Because this will tell us the image of the function. So, for example, the image of the function is starting from including minus, so this part of the K1, the K1. What is the K1? Is this guy. K is included and up toward infinity. It will be the range. So with example, I will tell you how we are using this idea. Look at this example. Define f z to z by f of x is equals to x squared minus 5x plus 5. Determine whether f is 1 to 1 and or onto. Okay. Now, for 1 to 1, f of x1 is equals to f of x2 implies x1 is equals to x2 or not. Let's check. So if f of x1 is equals to f of x2, this means that x1 square minus 5x1 plus 5 is equals to x square to the power 2 minus 5 times x2 plus 5. From here, the 5 guys cancels. What left? You have this one. Now, this you can write like what? 5 times x1 minus x2. In here, you can write this x1 minus x2, x1 plus x2. This simplify each other and you get what? x1 plus x2 is equals to 5. Of course, from here you can say that x1 cannot be equals to x2. Because, for example, x1 is equals to 2, x2 is equals to 3, they makes 5. So for that reason, we see that when f of x1 is equals to f of x2, x1 is not equals to x2. That means f is not 1 to 1. Okay? Do you understand this one?
Yes.
Okay. The other part is now more important. No, it's also important. But all of them important, but it's more connected. What I just explained here is f onto, or yeah. Now, this is a parabol. Okay. Now, a is bigger than 0.
Sir, I have a question.
Yes.
You record the lesson, right, sir?
I am recording the lesson. Yes.
Sir, why doesn't it work when I download it? It like works for 10 minutes, then it stops. All the recordings.
Oh, I will check this. I don't know. I will check. I just had this information from you. After the class, I will check and tell you, okay?
Sorry, I had this problem, and you need to download one video and wait for a couple of minutes, and then download the second video.
تمام.
I understand now your question. If you are downloading yourself, as your friends say, yes, please do it one by one.
تمام sir.
When
Thank you.
it's finished, you go to other one. But I am doing these things for you. I am putting in the model. Okay. I understand. There is a problem with the videos I put to the system. Now, yeah, thank you for your friends making everything clear. Okay. Now, let's turn back what we are doing. Graph of f of x is a parabol with vertex minus b over 2a, comma f of minus b of 2a. Now, it will be something like that, you know, concave up, and the vertex will be what? So here, what is a, what is b? A is here, right? B is what? Minus 5. So the vertex, the x coordinate will be minus b over 2a. That means 5 over 2. Because b is minus 5 times minus 5. Now the y coordinate is what? F of 5 over 2. So if you put 5 over 2 here and do these calculations, you will end up with minus 5 over 4. So this means that your range, so f of x, guys, can start from minus 5 over 4 and so on. So your range is closed interval from the left, minus 5 over 4 to the infinity. So with this information, we understand that range of f is not equals to z, to the target. So we say that it is not onto or not surjective. Do you understand this question?
Yes.
Okay, thank you very much. This was important. My friends, one student asked me why we started from chapter 1, chapter 2 from book. To answer this question, we need to look at our outline. In the outline, I need to find the outline first. 1 minute. In the outline, it doesn't start with chapter 1. Okay, let me. Actually, in the outline doesn't say. Okay. So, as you see, our schedule, which our coordinator sends us, says that we need to start with sets. If you look at your book, the sets will start with 2.1. For that reason, I started with 2.1. But of course, you can study previous chapters. You can have a nice background. Okay? So for that reason, I don't start with chapter 0 or chapter 1. But if you don't understand, you can always ask me. Okay, thank you for this question. Now, let's keep on what we are doing. So this was important question. Another question. Let g is from real numbers to real numbers. G of x is given as x squared. Okay, oh, I doubled this, but it's okay. Maybe, yeah, later on I can clean this. My friends, domain of this is what? Real numbers. Range of g is what? Non-negative real numbers. Are you agree with me? Because whatever
Yes,
guy
but
you take,
the parabola should be upward.
yeah, actually, if you look at, yeah, actually you can easily say, yeah, it's a good idea. My friend, just give me 1 minute. In here, I cannot play with this. Okay, tools, can I play? Oh, okay, very good. yeah, actually, where is this common thing? Common, yeah. So in here, pencil. It's like that, isn't it? And 0 is here. 0 is here. Sorry, I'm not that good. So 0, this is the graph of y is equals to x squared. So what happened? Range is what? Starting from 0 to upward. So this is non-negative real numbers. This is the reason. Because you cannot have positive here, okay? My friend, G is not 1-to-1. G is not 1-to-1 because take G3 and G over minus G of minus 3. G of 3 is equals to G of minus 3, but 3 is not equals to minus 3. So it's not 1-to-1. G is not onto. Why? Because when you solve this, the x guys is equals to square root y, but these are not real numbers. Okay? So you cannot find always, guys, in real numbers. You have to find from here. What else we have? We have these more examples to understand the lesson better. Let h is starting from closed interval 0 to infinity. It goes to real numbers. H of x is equals to x squared. H is 1-to-1. Because let's use this argument. H of x1 is equals to h of x2. Now this implies that what? X1 square is equals to x2 square. And then from here you can say x1 is equals to x2. This is the only possibility because your domain is starting from 0. These guys has to be bigger or equals to 0, so they have to be the same. So you cannot say like one of them is minus 3. Do you understand? So for example, your answer is 9, okay? X squared is equals to 9. Then you can say, oh, okay, x can be 3, x can be minus 3. But no, x cannot be minus 3 because all x are from here. They have to be positive. So from here, you are very safe to say that x1 is equals to x2. So it is 1-to-1. Okay?
Okay.
Yes. Now, how about this? This is a polynomial. Domain is what? Real number. Target is what? This R. It's 1-to-1. 2x1 minus 3 is equals to 2x2 minus 3 implies what? X1 is equals to x2. F is onto or surjective because any real number y can be expressed as y is equals to 2x minus 3 for x is equals to y plus 3 over 2. In other words, do you remember in the beginning of the class we said for any b in real numbers, b is equals to f of x. Okay, this is, yeah, 2x minus 3 has a solution. X is in real numbers. So here you can solve this for any b because if b is 2x minus 3, then x is what? B plus 3 over 2. And this is in real numbers. What is said here is just I want to express with the concepts which is given in the beginning of the class. I just want to write like that. Maybe you didn't understand this one. I just want to say this also. So then it is surjective. So sometimes to find surjective, you can go through this method or you can find the range. Okay? Yeah. Now, I would like to go on with special functions. I am sure that in calculus at least you solve these ones. The absolute value of a number x denoted is defined by like that. So if x is less than 0, is equals to minus x. If x is bigger or equals to 0, then it is x. The absolute value function is a function with domain R and range start from 0 to infinity. You can write this like that also. The y, guys, from real number, y is bigger or equals to 0. It is not one-to-one because can you see that absolute value of 2 is equals to absolute value of minus 2, but 2 is not equals to minus 2. So it is not one-to-one. We have floor function. For any real number x, the floor of x written like that, like, can you see like L? They are looking each other from right and left, like L's. Then between that you have x. So this is the greatest integer less than or equals to x. That is the unique integer satisfying this one, this equation. X minus 1 is less than floor of x, and this is less than or equals to x. Ceiling of x written this time upside down else, can you see that looking each other, is the least integer greater than or equal to x. That is the unique integer satisfying this time x is smaller or equals to the ceiling of x, and this is smaller than x plus 1. So for example, this is, we said what, floor, right? What is the floor of 2.01? It is 2. Because we are looking to definition. What is the definition? Greater integer less or equals to x. So the less than this one, which integer comes? 2. That's the reason. How about this? Floor of 199 is 1. 15 is already integer 15. Here, floor of minus 2.01. What is the greatest integer less than minus 2.01? So minus 2
3.
here, then minus 3 should be, isn't it? Because if you look at the real line, this guy is less than this one, isn't it? Understand? Minus 2 here, minus 3 here. Which one is less than minus 2? Minus 3 is less than. Minus 1 is bigger, isn't it? So for that reason,
Yes.
this is minus 3. Okay. How about ceiling? Now, ceiling means that least integer greater than or equal to x. So here, obviously 3. Here, 2. This is 15. This is, now, this is minus 2.01 somewhere here. And then you are looking to what? Definition you should look at. So according to the definition of ceiling, least integer greater than. So this means minus 2. Do you have questions about this?
It's okay.
Thank you very much. My dear friends, here there are some technical details given. For example, floor function has graph like that. So what is it saying? Yeah, these guys has both domain R. Okay, but range as z integers, because as you see, we always find some integer in the answers. Can you see that? So domains are real numbers, but ranges are integers. Okay, my friends, we are very happy to understand. Maybe you already know. We have identity function. Okay. Now, sometimes I skip some parts of this. Now, okay, for this definition, for any set A, the identity function on A is the function. Here it says that this word should be read as iota sub A. It's a kind of very technical Greek symbol. It comes, he said, from Greek symbol, iota sub A. So they say that you should read this iota sub A. This A to A defined by iota sub A of A is equals to A for all A. So basically, what does this guy do? So it applies any element from A, from the domain, and it pictures itself. Okay, so it's identity. You can write this in pairs form like that, A to A. So iota sub A, take A and pictures to A. A's are from your domain. Okay. So you can say that you have y is equals to x, for example. This is the graph of identity function on R, this one. So so instead of taking, so this is arbitrarily working, A is a set. Here, let's say A is real number. So f of x is equals to x. So this is actually what? Y is equals to x. Can you see that? This is identity function. If this is 1, this is also 1. Oh, okay. If this is 1, then this is 1. If this is 2, 2. For all x, of course, this is happening. This is the identity function on real numbers. Okay. Sorry. My friends, do you have question? Okay.
Yes, please. I have one question.
Yes.
Why the letter A is upside down?
Why upside down? What is upside down? You mean?
Letter A.
You mean the ceiling function or float functions? You mean?
No, not this page. The last one. Yes.
Yes.
The second line.
Okay. First line, second line.
No, not here. What you wrote?
What I wrote?
With the red line.
So this one or this one? This one?
No, the one under it.
Okay.
Fx equals to x.
Yes. Yes.
This
yes.
A. Why it's upside down?
Ah, okay. Many sorry. I didn't tell you this. You didn't hear about this, isn't it? Sorry, my friend. Yeah, I thought that you are knowing this, but you are very careful, student Yani. Many thanks. This means that for all x. For all x. This symbol means for all x. Okay? Thank you very much. Thank you very much. Great. You are very interested in the course. Thank you.
You're welcome.
Yes. My dear friends, we are on the way of functions. We have a good journey. We want to continue our journey, of course. By the way, I already opened the attendance in case I want to tell you.
Sir?
Yes.
Are you going to add these files to module also?
Yes, of course. Sherife, right? Sherife is asking this question. Yes, Sherife, don't worry.
Okay, thank you.
Yes, but if you already downloaded this book, yeah, but you know, but I sometimes write notes, so okay, I understand you.
Yes.
Yeah, I wrote a lot of, I hope you are okay with my writings, these things. I try to explain more, but my handwriting is not that good on this, you know, PDF. But I do my best, Sherife.
Okay.
And others. Yeah, okay, thank you. Okay.
Where can I find that PDF file?
My friend, I remember one student, but I don't know his or her name.
I have got PDF. If you want, I send you.
Okay.
One. Who is this? I don't know who's talking, but she is very helpful student. Yes, this helpful student is helping you. Please ask her. Sherifa, you.
Yes.
Please also send it to me if you can.
Okay.
Yes. So
Can you
Sherifa.
send on chat?
Okay. And Sherifa and I don't know who else. Please
Chat
help
now,
each other.
for you.
Okay. Thank you very much. Very good. Very good. Thank you. Thank you. Thank you. My friends, what is going on? At least let me read this and then we can have a break. We have a new journey. In our new journey, we will talk about inverse of a function. For this, we need to have some specific condition on the function we are talking about. Now, suppose that f is 1-to-1 onto function from a to b. Given any b in b, there exists a in a such that f of a is equals to b, because f is onto, we know this. And only one such a because f is 1-to-1, yes. Thus, for each b in b, there is precisely one pair of the form a to b in f. It follows the set ba, ab from b, obtained by reversing the order pairs of f, is a function from b to a. Since each element of b occurs precisely one as the first coordinate of an ordered pair. So, what is taught here can be explained in this example very clearly. Now, can you look at this and let's give a break after that. Example 13. A and B is given. Your function is this. This is 1-to-1. Am I right? 1 goes to x, 2 goes to y, 3 goes to z, 4 goes to 3. So all of them goes different things. This is also onto because range is what? X, y, z, t is equal to this. Now, so what is saying here, if you have a function which is 1-to-1 and onto, then you can have a function, okay? Later on we will say inverse of the function. You can just reverse the order of the pairs. So in here 1 was going to x, then now x goes to 1. While 2 was going to y, here in the f, in the reverse function, y goes to 2. Here 3 was going to z, now z goes to 3. 4 goes to t, now t goes to 4. Okay? We will continue with the details, but now I don't want to take your break time. So have a break, okay, my friend? And if you didn't understand, I can explain this again. Okay. Sorry. See you in 10 minutes.